We're going to take a look at separation of variables, which all falls under differential equations. They're going to be 3 tabs. First one is separation of variables. All right, so looking at an example, if dy dx is 4x over y, and y of 0 is equal to 5, then find an equation for y in terms of x. If you're given the derivative, how would you find the original function? Well, hopefully you said you would integrate both sides, but first you're going to need to put like terms on either side. So integrate both sides, but first put like terms on either side. This is a listening check. Color in, if given the derivative, how would you find the original function? What I wrote down in pink, basically. So what do I mean put like terms on either side? Put the y with the dy's, put the x's with the dx's. So go ahead and separate those. That's the separation of the variables. So it's going to be y dy, and then it's going to be 4x dx, and you're going to integrate that. So if you integrate both sides, you're going to get y squared over 2 equals 4x squared over 2 plus c. Right? Find out what c is. So remember, y of 0 is equal to 5. The 0 represents the x value, and the 5 represents the y value. So just plug those in. So you're going to get 5 squared, which is 25. Divided by 2 is equal to 4. And what's x? X is 0, so 0 squared over 2 plus c. So you're going to get, that goes to 0, so that's 25 over 2 is equal to c. So rewrite number 3, write out the solution, like the whole solution since I found out the c. So that's going to be y squared over 2 is equal to 4x squared plus 25 over 2. And I'm just going to put this here, but I see in the book that they don't really simplify, but I'm going to simplify this just because all of them have divided by 2, so I can just ignore all of those and just write y squared equals 4x squared plus 25. Just looks a little bit neater, but the one on the left is fine. All right, let's take a look at another example. It's pretty easy. Let's say we had dy dx is equal to 3x squared y, and y of 0 is equal to 2. And the question was, find an equation for y in terms of x. So again, the first thing you do is integrate both sides, but make sure you put the dy's with the y's and the dx's with the x's. So it's going to be dy times 1 over y equals, and then 3x squared dx. Integrate both sides. So the integral of that is log y. Integral of that is 3x cubed over 3 plus c. And then we have y of 0 is equal to 2. So the 0 is going to be your x value, and the 2 is going to be your y value. So now plug those in. So we're going to have log of 2, because that's your y value, equals 3, and then 0 cubed, which is 0, over 3, plus c. So it's going to be log of 2 is equal to c. Alright, go ahead and write out the solution. So log of y is equal to 3x cubed over 3 plus, now c is log 2. Listening check, color in log of 2 equals c. So they don't really like logs, so they're going to write it in exponential form. So I'm going to take the exponential form on both sides. Those 3's cancel, so it's going to be e to the x cubed plus log 2. And I don't know if you remember this, but the properties say that when you're adding them, you can separate them through multiplication. So it's going to be e to the x cubed times e to the log of 2. Once you have that, e and log 2, they're the opposites of one another, so they cancel out, just leaving the 2. So it's going to be e to the x cubed times 2, which obviously just rewriting the 2 in the front, y equals 2e to the x cubed. Alright, so it's pretty easy. Separation of values is really easy. But what they're going to do is, obviously, they're going to give you a word problem. Those are the ones that you really see. So we're going to take a look at that. First thing we need to take care of, though, all proportional functions use a rate in the same way. All proportional functions use a rate in the same way. We call that rate the constant of variation or the constant of proportionality. So it's a constant of variation or proportionality. And it is expressed in calculus as the listening check, color in constant of variation. dy dx is equal to k, which represents the constant, times y. Okay, so k is that constant we're talking about. Alright, so I'm gonna just quickly remind you what this means. So let's say you had cars, okay? So I'm just gonna draw 6 different cars. Each car obviously has 4 tires. Alright, so my question would be, how many tires are there if you had one car? How many tires are there if you had one car? So one car is obviously 4 tires. I count 4 tires. 2 cars is how many tires? 1, 2, 3, 4, 8. 8 tires. 3 cars is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tires. We could go on forever, but no one has time to count all these tires. So the tires are changing proportionally. The tires are changing proportionately. What does that mean? They're changing at the same rate per car. Really, they're changing 4 by 4 each time. Okay, so the number of tires is equal to 4 times the number of cars, which in calculus would be dy dx is equal to k times y, and k represents that 4, that number 4. It's the constant of variation. So this time we don't have to count how many tires per car. We can just use the constant of variation. So if we had 5 cars, instead of counting all those tires, I can just say, well, 4, which is my constant variation, times the 5, and that'll give me the 20 tires. Or I can count them all out and it'll be 20. Nobody has time for that. So just a quick refresher of what the constant of variation is. Alright, so let's take a look at an example. The rate of growth of the volume of a sphere is proportional to its volume. This is a listening check. Box example 3. If the volume of the sphere is initially 36 pi feet cubed and expands to 90 pi feet cubed after 1 second, find the volume of the sphere after 3 seconds. So a couple of things. Remember, rate has to deal with dy dx. It's proportional, so that means we're dealing with dy dx ky, and it's volume that's changing. So dv, so the volume is changing with respect to time. So dv dt, which would be the rate, is equal to k, and what is it that's changing? The volume v. So this is just a separation of variables, just what we're doing here. Integrate both sides, but first you need to put the v's with the v's and the k's with the t's with the t's. So it's going to be 1 over v dv equals k and then times dt. Integrate both sides. So we're going to get again log of v equals kt plus c. Now from the question, at t equals 0, because it uses the word initially. Okay, so we need to find c. At t equals 0, because it uses initially. So anytime you see initially, it's t equals 0, because that's the starting point. So at t equals 0, the velocity at t equals 0 is 36 pi. So all we're going to do is plug it in. So log of the velocity, which is 36 pi. So log of 36 pi is equal to k, which I don't know, t, which I do know is 0, plus c. And then k times 0 goes away, so c is equal to log of 36 pi. Okay. Now I'm going to rewrite that, including that. So log of v is equal to kt plus, instead of c, log of 36 pi. Okay, at t equals 1, the volume is 90 pi. So now I'm going to plug that in to find out what k is. So log of 90 pi equals k, and this time is 1, plus log of 36 pi. So now take log of 36 pi to the other side, so it becomes subtraction. And if you remember the properties of logs, whenever you have subtraction, it'll be log of the division of just the individual terms. And that simplifies to log of 5 over 2. It's a listening check. Circle k equals log of 5 over 2. So now I found k, I know what c is. I'm actually going to rewrite log of v. Instead of having log of v, I'm going to solve it for v. So you take the exponents of both sides, you're going to get v equals e to the kt plus log of 36 pi. And then separate those using the properties. That's v e to the kt times e log of 36 pi. Now that second one has e and log of 36 pi, so that's just going to go away, leaving 36 pi times e kt. So that's my new equation. It's just a little bit easier to work with than the logs. It just is less. So I'm just going to copy it down. And k is log of 5 over 2. So I'm putting in instead of k log of 5 over 2. So the question is, what is the volume at t equals 3 seconds? So the volume is equal to 36 pi e to the log of 5 over 2, and instead of t now it's 3 seconds. Alright, I'm just going to put the 3 in the beginning because you don't usually see it after. So that's going to be 36 pi e to the 3 log of 5 over 2. Which, using properties of log, we can put the 3 on top as a power. So that's going to be 36 pi e to the log 5 over 2 raised to the 3rd power. And then because we have e and log, that goes away, leaving the 5 over 2 cubed times the 36 pi. So that's going to give me the volume, which is 36 pi times 5 cubed is 125, 2 cubed is 8, which simplifies to, like, if I divide by 4, 36 is going to become 9, and 8 is going to become 2. So I've got 9 times 125, which is 1125 pi over 2. And that's my volume at t equals 3. And that's pretty much it. So that's the hardest that you're going to get with separation of values. Okay, so let's practice.